whole event and also connecting with you people. Let me just give a little brief about the university where you are, so that friends, what they are looking for is a research collaboration from the university in which joint collaborative R&D is one important area where we can look at how do we, there are bilateral schemes, there are multilateral schemes in which we can participate in the grants which we can apply together. In the strength where there's a commonality as well as when there is a convergence of interests in research and development, so we can look at that possible collaborative R&D. The other area which they are looking at is joint PhDs, because if you have an ongoing PhD program and you have the new scholars, so can we mentor the PhD scholars together, both from academia? But Dr. AK, please. Is Dr. AK Singh, my colleague, Dr. AK Singh, Dr. Neeraj Sharma? And so they are looking at collaborative R&D, joint mentoring of PhD, because I just asked them, what do you have in mind? Once you visit a country or visit an institution, everyone looks for a certain outcome. This is what I want to take away from as an outcome to their country and to their university and the industry. So I asked them, and they said one is collaborative R&D. And the second area is the collaborative PhDs, joint PhD mentoring in the areas of common interest. So where we can even look at the topic of interest to both our universities and the industry. Then the third one, they are looking at master's level, because their collaboration, they are pitching at master's and doctoral level, because undergraduate level is mostly in French. So that is why the language will be a challenge for those who may not know the French language. So that is why she said that let us look at master's dissertation, 6 months dissertation in a semester, which you do. Maybe you can do it there. They may be able to support such collaborative R&D. I think these are certain areas she has spelled out. And from the industry side, they have come out with a sensor to assess the indoor air quality, particularly for the microbial contamination. If there is a virus, bacteria, fungus in the air, so how would you assess? So they have developed a sensor, and which they will be talking about. And this is as a startup. They are a company, new startup, but they are looking for partners. So that is where I have invited virology and immunology director and the senior scientists. And then they also have interest in space. Space science and technology is a major area, including and one of the best in the world. Only one in the world. So that they are so proud of. So we can look at in space research, what is that we can do together. Today, actually, Prasad and Shivani has gone to DRDO Bhavan. That's why they are not here. And they are bidding for another project there. So today is the 8:30, they had to be there. So we will listen to them, and more than our talking, I will just give a brief, because presentation we will give it after we hear from you people that what is that you want to do, because your time is limited. You like to leave by 12 o'clock or so. So that's the reason, constraint of time. So instead of we talking, we want to listen to you. Then we will introduce ourselves and you will know that. So with this, I welcome you, and I would request Ms. Oriana to say a few words, and then Mike can take over.
Well, thank you so much for the welcome. As mentioned, my name is Oriana Bertucci. I'm the Director of International Relations at the University of Liège. And so in our office, we manage all partnerships at the research level, at the doctoral level, at the master's level, and at the bachelor's level. But as mentioned, most of our programs are in French. So, and we look at mobility agreements and local partnerships and international partnerships. And so we have had, over the past decade, made several relationships with different Indian universities. As mentioned, so we built the first liquid mirror telescope, and it was with India that we decided that that was the place to be. And so because we've had some successful partnerships, when the Belgian government announced this visit, we thought, okay, we need to go and we need to explore. We need to meet with other institutions. We have about 55 Indian students currently enrolled at the university. Most are doing doctoral studies. And we have about 40 faculty and scientific researchers who are also originally from India. And so because it has worked very well in the past, we know that you have a much larger country than we do and a much larger population. And so we often get requests from different Indian institutions, but it's a little bit hard when we don't know anybody. When our researchers, for us, it's extremely important that our researchers have partnerships, because when they have a partnership, that's going to make the science advance. That's going to make the science live, and that's what we want. And so in coming for this visit, when we contacted AWEX, they said, we know the landscape a little bit better. They're here on the ground, and they said, you must come visit Amity. So here we are. I met already my friend in aerospace, so I think we definitely have perhaps some opportunities to explore, to look at. But our university is a little bit smaller than yours. We're about 26,000 students, over 11 faculties, and really our applied science. So a broad range of engineering, aerospace, mechanical, chemical, engineering, health sciences, business. Those are really the areas where we have a lot of strengths, and our faculties are open and looking for partnerships. So I won't take too much time because I know we have a tight schedule, but yeah, so let's talk a little bit about aerospace, because aerospace engineering for us is quite a large program. We have a large portion of our research budget that is dedicated to aerospace engineering. And then within our engineering faculty, within kind of in partnership with aerospace, is also so the physics, obviously, department. We have a large civil engineering, mechanical engineering programs. We have masters in space science, and then masters in biomedical engineering. That's also one of our newer programs, and looking at really the relationship between different biomedical fields and engineering. And so I think, as mentioned, when we talk about a joint PhD, one of the things that we like in a joint PhD, or having external members on our student juries for their dissertation, is that it allows for a shared opportunity of research between not only the professors, but then the students have long-term relationships with their international partner. And I think for us, space science seems like a natural fit, because we already have, the telescope here. We are meeting this afternoon. We have an event at the planetarium. Members of your Minister of Governments are going to be present, because we recognize that it's not just at the university level that we need to have those relationships, but it's with the government, who is allowing us space, allowing us funding. And so for us, we see that as a natural partnership between the institutions, especially here in I'll say the greater Delhi region, because our telescope is at the Aries Observatory in Devastal. So we have some partnerships in the south, but it's a little farther for them to come. Yeah, debris management is really the current focus of what they're doing, which is, for those of you who know, something that is increasingly becoming an important field to develop, because with the increase in traffic in space, if I could say it that way, we need to be able to monitor what is out there. And so the telescope that we have currently here it runs 24 hours a day, 7 days a week. They're constantly monitoring the images that they get. And so that is allowing us to track what we see. And probably about 50% of what we see, we can identify. And then of the other 50%, there is one part that is of military use, and so we can identify it as for military use only. But then there's about 25% that we have no idea what it is. And so we need to develop it, and we need to be able to identify it for the future.
That is the biggest one. Are you talking of Vera-C Rubin observatory?
It's the liquid mirror telescope mirror. Yeah. And just for the anecdote, so to know, when Professor Jean Surdesh, who's not here with me this morning, he's currently at the planetarium, but he's here on the visit. When he suggested this idea about 10 years ago, they said, it can't be done. It can't be done. And when we were looking, the University of Liège has a number of telescopes in Chile. And so the Chilean government was very interested in partnering with us. And in some of the researchers that we were working with said, oh, it can't be done. And through different opportunities, Professor Shodesh made some contacts here in India, and they said, we think it can be done, and we think we know where we can build it. And so that's where he is. I'm sorry that he's not with us here this morning, because he is I think part of his heart is now Indian, because the partnerships that he had really believed in him, and he received a lot of government support, and so through many of the research projects that they have developed, it's through the BINA, which is the Belgian Indian relationship in aerospace and. I'm not the scientist, so that's a hard question for me. But yeah, I can. Yes, absolutely, absolutely, yeah. Really good. Thank you.
Thank you, Ms. Oriana. Let's listen to Mike.
Can you hear me? Yeah. Thank you, everyone, to be here. So we represent a small startup. We are in the phase of development of a pathogen detection device. So actually, for the moment in Belgium, if you are in critical environment, if there is any problem in a room or something, you have to do a sampling, sending to an analysis center, and then send it back. And it has some challenges related with, for example, hospitals who need their operating room to function all the time. That's one of the many examples. If you have a food industry, you are on production chain, you have a problem with a pathogen, you have to stop the production line, send the sample, figure out where the problem is, and then coming back with a solution. So regarding all of this, what we decide is to launch this startup with Louis, my CTO, who can explain to you in detail or some details of the technology we are going to implement. And so we decided to make a joint venture with not University of Liège, but University of Brussels, ULB. And so we work with a specific department where we decided to collaborate with them for their competence because they work with the NASA. And the idea for us is not only to figure out the good technology to be able to identify in real time in the airflow or water flows all the pathogens. So he can explain to you a little bit about the technology itself. I know there are some people who would be very interested. Actually, it's patent pending, so we will see how in detail we can go into the technology, but that's the idea to share with you today. And so, as I said, we work with this department of the ULB because one of their main competence is to be able to miniaturize the systems. So the component and so on, because they work with NASA. So they have already done some specific component that is in the space, yes. Exactly. So the importance of being here today is, of course, that I am the CEO of the company, and my challenge is to make sure that Louis get all the support from maybe more experienced people, where when we will need to make decisions all the time regarding the technology we use, that has implication for us. And of course, we want to put it on the market at one point. And, there's a certification that are completely different from country or even continent, completely different. So it could be complicated. So every support would be really welcome. That's the first thing. So this is where we are. We start now the R&D phase with ULB in March of this year. We expect to have a first prototype by June 2026, maybe a little bit later. And regarding the specifics identification, what do we do? Actually, we have collected from some of the government representative of Belgium, so the health government, health and safety, food safety government. Plus, we have a specific task force in Belgium where we collaborate with. It's called Cienzano. Cienzano is they make the rules, or they write the new rules regarding the indoor and outdoor air quality. And in the specifics environment, for example, we collaborate now with several hospitals. First one is UZ Brussels, who installed the system that is already operational with which is called Air Shield, which has devices that detect the air quality, not really pathogen, but actually PM, VOC, and so on, CO2, humidity. Well, that's the other part of the system, because we detect and we also activate countermeasure when it's needed. So that's the first thing. Why do we do that? To collect data.
Who is funding?
Funding. So we have two different funding. We have subsidies from the federal government, from the regional government, for about 60 to 70% of the whole development budget, and the rest is private funding for the moment. This is where we are. And what I think was important is that we will first of all identify some pathogen. There's gazillions of them. And why we choose the specific one? Because of the use case. The hospitals or the laboratory or the food industry tell us which ones among the list, which one they would like us to be able to identify. And then step by step, with the different version of the prototype, we will increase the number of pathogen that we can identify. So there will be a prototype 1 that will be tested, and the comparison of the result of the machine compared to the actual system that exists already in the laboratory in the hospital will make sure that the system functions very good. So here we are today, because it's the first time we come to India. I see that all the people that are around the table are the right people to talk to. So I'm very happy that you are here. Thank you. And actually, yes, collaboration could be of a lot of different kinds. We could each time Louis and the team of the ULB makes a decision regarding the technology, we could use your advice. We could use your opinion about it. Are we going to the right direction? If he faces some challenges regarding the technology, because we don't talk only about biomed technology, we also have to include all the components into a box. And we need to design the box. We need to add electricity. We need to add a ventilation system. We are designing specific component with 3D printing. So this is not only biomed. This is also engineering, electrical engineering, that we would need some support. That would be great. And then finally, when these devices are going to send the data, we need analysts. I'm talking about not only data scientists to split from just 1 second, to split from to detect the real thing and avoid the noise, so to say. And then from there on, you have to apply AI that will be supporting us to identify the right ones. And not only AI, but you have also all these biomedical expertise that we need, like infectiologist, immunologist, etc. So that's it. It's just an open discussion. That's it. But I would like maybe Louis to make a little comment about the technical. We are here in an university, so we are not competitor. I think it's more that we can collaborate, but we never know, you know. So, but thank you for listening to me.
All right, thank you everyone for coming in today. So, as Michael said, I'm the CTO of the company. So, here on the behalf of the pathogen sensor unit that we wanted, there is some characteristic that people as in pharmaceutical, hospitals, food industry are really in need is some devices that can run all the time in real time. They can do real-time analysis, and they can need less consummant reactives or any kind of maintenance in the process of analyzing it. So what we are building is devices that will concentrate the airborne pathogens that you will have all over the air in a particular environment, control it into a small processing unit, and then analyzing it to determine its particular fingerprint. And by doing so, we'll compare it to databases of those particular fingerprints to link those actual data we receive from the sensor to the one we have already produced in laboratories to send an alert or any kind of recommendation regardless to the infectiosity of the pathogen that we are sensing, and telling to the client, the people that are in need, be careful, right now we detect those kind of airborne pathogen in the air in these operating room, for example, you need to take care and do this, and this. That's the idea of it. So, of course, there is so much different pathogen in the world that we'll not be able to identify all of them at once. So at some point, what we'll also need to do is to improve these databases of pathogens with several different ones. So we are discussing with other partners all over the world to see in different kind of environment, because as I'm sure you were aware of it, India is very different from Iran in Belgium. So what we intend to do is to also collaborate with academics and partners to do some testing. So Michael said we already have a partnership with the ULiège Brussels to have it installed in their hospitals. And when they've done that, they will do the comparison test on their side and on our side to see if both results are coherent. We want also to do those kind of things in other countries, such as in India, to have a good overview about what are the pathogens and what are the problematics, because as I'm sure you well know, some pathogens are very specific and very similar in their internal structure, so it's very difficult to distinguish them, even with the new the emerging technology that we try to produce. So we want to increase the size of our team and our testing sites to have a good overview on that. And as a university, you have all the facility to also do the analysis to confirm the result that we have sent. And so that's why we're thinking about working on with university.
So, till yet, how many pathogens you have tested, like including both bacteria and viruses? Because as you have mentioned, there are lots of bacteria and viruses in the environment. So, what is your strategy to calibrate? Because see, bacteria and viruses vary place to place, right?
Exactly.
If you're going to a new environment, there may be new bacteria, new virus. So, what is
Exactly.
your strategy for it?
Exactly. So on that matter, we can say we have already 20 different pathogens that we are looking at. The problematics you are in is at which level you want to identify them. So the first step that we succeed is to identify and separate the different kinds, so bacteria, viruses, and fungi. That's already done. Next, we go to the next level with those 20 different pathogens. We can identify them, so Aspergillus and so on. We can identify the family species of the pathogen, but for the subspecies of the pathogen, it start to get very complicated. So that's the one also we need to take care. Michael said about letter version. So this one is, I told you, building in ULB, we'll need tests on that, but we'll not stop on there. We want to improve then the technology even more to reach this particular level of precision and manage to identify the real subspecies of all of the pathogen that we are sensing.
Okay, just a no, I think let me tell you a very, very wonderful topic and much, much needed. I know many agencies in this country who would be more than interested to work with you. One.
Don't hesitate to put us in contact.
Okay. Number one. Number two. What is the science of your sensor? That if science means on what basis you are identifying these.
It's based, I told you we needed to avoid the use of reactive, and we don't want to do some cultures and so on as some others are doing. So what we're using is some spectroscopic properties of the different
Raman
pathogen.
spectroscopy you're using?
Yes. Sorry?
Raman spectroscopy?
A combination of different spectroscopic techniques, but there is Raman among that, and we hope to achieve, to find those fingerprints and combining and using IA to analyze the complex spectroscopic data from the sensor and compare it to the databases made from the same devices, but in laboratory and controlled environment. As we've seen for the first pathogen, we tried that there is good result now. So yeah, that's the idea behind the technology. There is other module in the devices to avoid cross-contamination, to avoid separate between bacteria viruses and so on.
By using AI, you are able to segregate different.
That's the idea. Yes. Yes.
Are you able to do that?
Until now, it's controlled environment. So we are in the project with ULB will start. We increase in speed in a few weeks now in March, but we haven't done mixed sample yet.
Basically, what you are looking for in India, you are looking for new pathogens, or you want to enhance your database so that you can segregate, because you are detecting them in a very fixed environment.
That's it.
Your sample is very simple.
Yes. At the time, of course, it will get complicated over time.
Your
but
sample is very simple.
Yes, at the time, yes.
Huh?
Yes.
And I can understand where you are targeting for in future.
So that's really the idea. That's why we install it into hospital and so on, because they're very complex environment and so on.
To detect toxins also?
Toxin, we haven't focused on that yet, to be honest, no.
Because in the food industry, toxins are of equal concern.
The question is not, we needed to start from some point, right? So what we've done is that we talked with the regulator. We talked with people who write the new rules regarding the air quality management, not monitoring only. Monitoring, analysis, and recommendation. These persons are working in a laboratory in hospitals, and they have put a list of first pathogen to detect.
No, sir, for that matter, for food industry, if you deploy a simple device which detects any new entry or an alien thing, that would suffice. But you are not restricting yourself to that. You are going beyond that.
Of course, of course.
Are you also suggesting corrections after that? Once you identify the pathogen,
yes,
in a, let's say in the food industry or in a hospital or something, and you say that these are the the levels of pathogens, right?
Yes.
Which is, let's say, beyond the admissible limits. Are you then suggesting how to tackle it? Or you are just telling that, okay, this is what it is, and that's it?
The idea is to not only to detect, but also to make...
Exactly. So I think these two have to be clubbed together.
Yes.
Otherwise, just by detecting it doesn't make any sense.
Absolutely. So, in fact, this idea will be included into Air Shield, which is a product that we already have for classical air quality, so PM, VOC, CO2, and so on. And it's composed of several modules. First one is CFD simulation, so computational fluid dynamics, to determine where to install the sensor. We've seen on research and on analysis and simulation we've done that it's very important when you install your sensor, because due to the airflow, sometimes you will not reach the pathogen that are really in the air, but due to the airflow, they will just not reach your sensor. So the installment place is really important. Then the data are sent to the databases, predictive model analyze them, predict the future trends, and activate in a smart way the countermeasure available or that we can recommend. So for instance, instead of just running the ventilation all the time and costing a lot of energy and money, of course, the predictive model will trigger it just the right time. So for instance, in 1 hour for 20 minutes, it will write down the ventilation or the purification system installed for cleaning the air and letting you sure that you are always below the level of pollutant accepted by OMS. So,
on the wet part, the pathogen you are detecting.
yes.
So, and as I understand, up to now, we are detecting at a single level basis.
Yes.
Mixed yet. But have you ever done the blind tests? Like you don't know the pathogen, you screen something and go back to your data set with the fingerprints and check whether there is accuracy. If yes, what is the percentage of accuracy?
Yes, of course. We haven't done it yet, but of course it's in the process. So it will be part of the work of the ULB laboratory. So we've acquired some of the pathogen, and UZ Brussels will also provide us from pathogen they have in their fridge to do those testing. And so we intend to do the blind test. That's the idea, to finally be able to identify from any kind of sample, air sample, if there is pathogen and which kind of pathogen is in the sample. Yes.
Then if you rely on Belgium only and you have a long future look,
yes,
how you can cope up with other pathogens in other countries, because the variant, suppose for hospital cases, like nosocomial bacterial infection is the
exactly
most
difficult. Yes.
On the streptococcus, different species cause the main trouble, right?
Exactly.
And even in those two species, in each species, within subspecies, the variation a lot in European country and American continent.
But this is why we are here.
And that thing is very difficult to catch with Raman spectra, or even if you combine the things. So you need to go back to wet lab and verify, you can indeed do, and that percentage of reliability should be more than 90%.
Of course.
To be very honest.
Of course. And
what is your approach in that direction?
That's why we wanted some to work with other countries and so on, because we want to also avoid the result of false positive, so having something detected and it's not the one that is reality presented your sample. So that's why we need to have a really good overview about what is done, and part of the work, that's the one that we will have someone, biomed people that will be hired into the company to improve all the time, in parallel of the work of the ULB, the databases of pathogen. So the idea will be to take sample from all over the world. So we take about, bank, genome bank and so on, then give them some pathogen type to sample to send us to improve the database to our laboratory, but it can be also done on the country of visit. And because everything is decentralized, so the machine is analyzing it and send you just a fingerprint of the what is analyzed, of course, can be done all over the world with a lot of partners on that to improve a little more the research. We want to have, for instance, a pathogen, it is two different species, one in Europe, one in India. We want to have that and to analyze them to see what can be the really small difference in fingerprinting pattern, and to be able to say this kind of pathogen and there is this kind of origin.
Dr. Louis, you said you have an inventory of about 20 pathogens.
At the time, yes.
At the time.
But the question is, how specifically and what's the sensitivity of identifying pathogens which you have in your laboratory at the moment?
So, I'm sure you know, the concentration of airborne pathogen are very low in the air, and even more when there is high mass of the pathogen. So their tendency to just fall on the floor or fall on the surfaces and not go into the sensor. And so now we have typical concentration of 10 -4 to 10 -5, if I remember well the number, but we intend to have the real concentration of what we have in airborne, so 10 -6. Of course. But the process of the calibration process and the tuning of the different spectrometer that will analyze the sample will be part also of the work of the ULiège, and very important work, because the calibration and the process to make everything on that working is very important, because if we are not able to reach low enough concentration to identify the sample, it will not work and will be usable in critical environments such as white room and so on. So at the time, it's a proof of concept of the technology can be used to identify the pathogen, and then we will tune every parameters on that of the machine to trigger those to reach those soil level concentration.
Your patent relies on AI model. You know, what is the USP? What is the patentability of your technology? Uniqueness.
Well, on that, how can I say? It's in fact, there is a lot of module in that. There is also microfluidic. There is also some electrocharger inside it. So there is a lot of different parts of in this machine, in this kind of sensor, and that's the whole machine that we want to patent. Then what we will provide to people, sell to people, it's more the services as for air shield. So the air shield I presented you before, we will just replace the classical air quality sensor with the pathogen one, which will also include the classical air quality for calibration purpose, but that's something else, to be able to, how can I say? Exactly. That's true,
Wondering, like, the pathogens are dynamic in nature.
Yes.
And like your sensor acquisition speed is enough to capture like that pathogens, because these are dynamics. And
on that, yes. The first test that we have done have shown that this matter doesn't affect that much what we are doing, because there is pre-treatment of the sample before entering the analyzer, spectroscopic analyzer in the devices. But no, I think that's it. But for, of course, if you're talking about mutation or evolution of the pathogen type, if you can say, of course, the databases and the research will be all over the time and in continuous. We cannot stop just with a few selected one. We will have to have someone 100% of the time that analyze those pathogens more and more to even improve the databases, and perhaps with the later version of the model, perhaps some of the result from the databases will be to be thrown away, that will not be okay anymore. So we have to do the test ever again if the pathogen has changed its internal structure or ADN structure. But we already know about that, and so that's what we will do on the company. So having someone 100% of the time that will do the analysis to complete the databases.
There is a catch in this question. Suppose it has mutated in such a way that its signature remains the same, but pathogenicity changes.
But pathogen as well?
That is difficult to.
Yeah.
That's a very difficult one. That's a very problematic, and that's why we want to have a broader number of pathogens as possible to see those kind, because perhaps it will work for 90% of the time, and there is one pathogen.
Your sample is too simple.
Yeah, exactly. Of course, that's totally true.
and
Yeah. But a wonderful starting.
Wonderful starting.
Let me tell you, I appreciate that.
Thank you.
as it is spectrometer So it can detect a sample at a time, no? One sample at a time. Like it is not imaging based. It is point based detection or.
In fact, so it will work by seconds. So part of the sample will be stored into a microchamber for concentration purposes and for the iteration. And so they will, I can say, pass one at a time into the analysis chamber. So you will have, we separate them regarding the sizes and structures. So that we will have all the viruses that will come first, and it will take like 1 to 4 seconds for the analysis to be sure that we have a good fingerprint. Then we will have the bacteria, and we will have the fungi, if there is. If there isn't, of course, we'll have a blank line and some noises.
Single pathogen detection or in multiplexing so that you can have a spectrum of pathogens. And then second point is the point of care, a standalone system.
Yes.
Okay.
That is point of care, you put specific examples, or you just leave it there as a standalone.
No. That's we don't want to take sample. It's really as for the classical quality sensor. It's a devices that will be installed on where the CFD simulation told us, but you put it on the wall, for instance. The simulation told you put it there, and you let it down, and they will just keep take the air from the environment, goes into the devices, and then analyze them.
But you haven't gone so far to the natural level.
Yeah, or now it's only on controlled environment because we need to manipulate those pathogens and so install on oven and so on, control environment. Yes.
Yeah. So the
Harmful gases.
Harmful gases is also something that is really searching for. So it's, if I heard well your question, it's like the VOC, so volatile organic compound. So it's also something that people are really wanted since a few times. We are working with a company that's building those kind of sensors. So apparently it's semiconductors based, and they can sense what kind of VOC, but the problem is that you need to build it for each kind of gases. So there is a list of that, and we intend in our device, in the later version, of course, to include those kind of things into the devices. So, for instance, we already have classical air quality sensor inside the pathogen sensor unit to still have a control over quality inside the room, but we intend also in V2, V3 or later version of the device that will not treat pathogen to include those kind of VOC to really have a good understanding of anything that's happening in the air, in the gas phases.
So like in Amity University, we have SO2 sensor, NO2 sensor, methane sensor. So that's why I asked.
Exactly.
The basic research has been done. The technologies are at TRL 3 and 4. We have the lab scale prototype. We can show it to you, and we are looking forward to have the collaboration with you. Yes.
With pleasure.
With the permission of chair.
On any conventional techniques to validate your product?
Sorry?
Are you relying on any conventional technique to validate your product?
Yes, of course.
Not yet.
Not yet, but of course we will do that. That's the idea.
Very optimistic, and we run with time machine for 1 year.
Yes.
You have a pre-built primary prototype.
Yes.
And we will help you to develop both from engineering side and to validate the pathogen character.
Yes.
Where the fund will come from?
Sorry?
Where the fund will come from? How you will get the funding?
All right. Okay. So
Every step.
yes.
Needs money, right?
That's true. So as we are a startup, it's mainly, as we said, subsidies. So 7 to 80% is made from subsidies. The whole project is paid by the Wallonia region. So they will pay for the research, for the hiring of the biomed technician to do the databases and so on, the testing. And we go to the test phases in real environment in hospital. They already agree on that, and they will do the comparative study on that. But for the next part, for the V2, for increased collaboration and so on, we need to figure it out how to achieve that, because we know about European funding, but to be honest, we don't know yet how to deal with worldwide subsidies or how to obtain obtain that. We think that having those first use cases in hospital will help us to reach money from all over the world and perhaps financing it. We met in the economic mission a lot of industry that want those kind of devices. One of the people that was just built a potato factory in India, and they want those kind of devices installed in the production line. So when they will show that there is good result on it, we hope that the machine will work itself.
What exactly you're looking for from let's say for India? What exactly is your
About the subsidies or about the scientific part? Collaborate. So I told you, the improving the databases when the result will be good enough to see if there is some differences between.
You need to install it somewhere in India.
Yeah, that's it. We will send you some devices. Exactly. We need some more data.
Yeah. Funding. So because without those verification.
Yes, of course.
Go for money.
Yes.
You need a significant amount.
Of course.
There.
Of course. That's true.
Data ship will collect. The samples are
to be analyzed.
Served there.
Yes.
Wait lab. Do the genomics.
Yes.
See their
Okay.
Exactly.
Right.
On that, we want to do exactly the same as we do with UZ and UZ Brussels. We're working with them since a bit of time now because they are looking for equality as well. But they just provide it. We don't pay them for that. They just the natural working of the lab, of the analysis lab of the hospital, they're doing on that, and we will use that as a startup because it costs no money. And when at that time when it's finished, it's when we will try to reach some investors, some other partners, some other funding, and go international as in India, perhaps in other countries and so on.
And we will discuss this. You have
so I just want to add.
They have to leave in 15 minutes, but she will be with us up to another half an hour, 40 minutes.
So this is really of interest to me because I am into microbiology, immunology, as well as public health. So this really fascinates me. I have done a lot of studies, surveillance studies of microbes in the environment, in the water sample, in fruit juice samples, in clinical settings. So I've done the surveillance and then also look for the antibiotic resistance profile of those bacteria. I have done a lot of studies on Streptococcus pyogenes, and we know that there are more than 200 types of Streptococcus in the community. And the problem is not all the strains or the types are pathogenic. So that will be a problem because we may detect Streptococcus, but it may not be pathogenic. So
exactly. That's will be done on future version of the product because at first, and what we are seeing on the test right now is we are just stopping just before on that. So on Streptococcus, we can only say it's Streptococcus and no more yet. And what will be done, but we don't know yet how to do it or to deal with it yet because, the project is 2 years long. So perhaps, yes, that's something yes, but we need to discuss on that. For now, industry that we talk to are very happy about this level of identification. So at first, it's okay for them that we go with it. But of course, in later version, that's the idea. We want to have the real subspecies of all the pathogen that we had senses to. So if there is 100 variant of Streptococcus, we want to have a database with those 100 and to identify which them are 100. But to be honest, this one in the actual form of the project is not taking into account because it will be done in later version of the project. We want to have this as ready as quick as possible, and when it's done, then we have a lot of idea on that to improve and to.
I think he wants to sum up, and then I will give my views on this. Yeah,
okay, thank you. Yes, of course. What is good, and I would like to thank everyone, is that you have questions. So that's good. I really apologize that the fact that we cannot stay much longer, but when your two yeah, my flight is. I'm sorry, and we tried to say to the organizer of this Belgium economic mission that we would like to just adjust the time. It was not possible, so I apologize for that. To be very quick, but aside of this, collaboration, we can talk about funding, we can talk about what type of, you have developed some specific sensors, you have the knowledge and the experience of people who has competences in the field, like in immunology or anything. We, of course, would like to extend the collaboration. Up to now, each time we collaborate with the healthcare government of Belgium. They support us. The government of Wallonia support us. So because there is an interest, because the world has changed till now, you have been COVID, pandemic, everybody was stuck in place for 2 years, killing the economy. So we don't want that anymore. So what we would like to do is to make a little contribution, as much as we can, with our system, to be able to inform the government of something goes wrong in this region. Take responsibility, do something before it touches the whole world. So I'm not saying that I'm that big ambitious, but let's say if we can contribute all together, that would be good. If you talk about funding, up to now, we had never a problem. And that's my job. So believe me, I can do it. The next thing is collaboration. Louis, the team of the university, we cannot do it on our own. We cannot stay in Belgium. As you say, you talked about dynamic, you talked about all the different things. We understand that and we know the challenges. We are a small team, and of course we would like to extend the team.
Okay,
the team, you see what I mean? Is it everybody understood? So thank you for listening. Voilà. Hello.
So good morning. I'm Professor Tanu Jindal, and oceanography is one of the area has been mentioned in the mail. So I am also director oceanography and atmospheric sciences. So we have two projects working in that. One is from Southern Ocean. We have extracted an algae, which as a psychrophilic algae, which degrades surfactants in the Yamuna River. The foaming of Yamuna River problem will be solved by the bacteria extracted by extremophiles. Second one is psychrophilic algae, which produces biofuel in the cold temperature. I think this is of your concern, where in ambient cold temperature we can produce biofuel. And thirdly, we have also a mega project on seaweeds valorization from Andaman Nicobars. So there also from seaweeds we can make useful products. Seaweeds. Seaweeds from the ocean.
Okay.
Yes. So use of the seaweeds for the nutraceutical products. For example, we want to make a nori sheet kind of thing, which is very much in demand for making sushi. So these are the three areas. And it's very expensive also. So that is what is on my mind. So these three mega projects and outcomes of our Southern Ocean and also Andaman Nicobar Ocean, we have been working on, and I would like to collaborate on the three subjects. Thank you. Yes. Yes. Yes.
They are also looking into developing various systems for monitoring air quality. So there also you can.
Yeah. So I'm glad to share that we have a continuous air pollution monitoring station at our campus itself. And I have recently developed a sustainable air purifier, which works on photocatalytic method. For the first time, I've used UV light in the air purification system, and we are enhancing the photocatalysis by using nano particles. So this is the latest invention we have done, and we are in touch with the government to make a sensor calibration unit at MET. Since we have a dual system of monitoring, one is by sensor, another by manual methods. So in this setup, a setup for calibration of various kinds of sensors available in the market.
Right. Okay, good.
Thank you.
So this is the capability. Let me sum up since you people have to leave. First of all, we want to congratulate you on this very unique, very valuable R&D contribution which you have made as a startup in the field of detecting pathogens. Because this is going to be very important, whether it is spontaneous, the breakout, an outbreak which we saw with corona, or it could be man-made. It's a bio threat, like a bio warfare or bioterrorism. If it happens, how do you detect it early and then give the intervention? So both ways.
an industry and so on. So we already contact with Esther in Belgium because we are there with weapon and so on. And so at some point, that's also the idea. That's why we're also working with governments, because if there is the need on that, we cannot have access to those trends of pathogen that are locked away in some laboratories, but we can send our devices to them. They can do the analysis on them, send the data to the cloud to the databases, and then perhaps we can include them into the database. That's one of the ideas we had. So at some point we'll have to take that into account. Yes.
Because India is has launched a major initiative on biothreat mitigation after this corona, and DRDO deals with that, where I served earlier for 40 years, and we in fact made the blueprint for the country. How do we handle biothreat mitigation? So, in which early detection, personal protection, collective protection, decontamination, medical management, the whole spectrum has been given. So, in which your detection, this sensor which you have used is very, very important, because this will be a standalone sensor. It's not the point of contact, standalone sensor, and will suck the air, concentrate the pathogen so that it comes to a threshold of detection, and then you will detect it. So the one which you have made is actually concentrating the pathogens to a threshold and then detected by the Raman spectroscopy, if I have understood correctly. And then to give the intelligence for detection, you are going to use data analytics, AI, machine learning, deep learning, so that the machine will look at the patterns and give the correct the decision support for the people to intervene. So this is what your system is, in which Amity has got tremendous capability. Why I'm telling this, having analyzed your needs, first is we have an Amity Institute of Virology and Immunology. So which he heads, Dr. Datta heads, Dr. Devendra Toor is from there with a lot of collaboration, a lot of experience these two people have in the bio threat mitigation as well as bio threat agents to be detection. Then we have a BSL-2 plus facility. Here in Amity, we have BSL-2 plus, which is required for identifying the pathogen, handling it, and so we have that facility also available. The third aspect is we have the sensor capability, sensor development. We already have a core competence. Like, for example, biosensors. We have worked on biosensor. We have worked on chemical gas sensors. We have worked on chemical sensors. So we have experience in sensor development. Dr. V.K. Jain and the team, as well as others, and like Tinku Basu, and these people have already developed sensors, biosensors. Then the fourth aspect is AI. We have a very strong AI center of excellence. I wish you had time. Maybe you should visit. The first phase, we have put a facility for 10 petaflop computing capability, which is huge, much good enough for your work. So we have that AI center of excellence with this is a NVIDIA system which we have put there. And so this AI capability, data center, we have a data science center here. And so we have experts in all the fields what is required for you to handhold. So Amity will be very happy to partner with you, Mike and Louis. And not only that human resource we have the infrastructure available, we have the expertise available to contribute for upgrading the capability you have already brought to a certain level. And then we will handhold you and be a partner in the co-development of your system. So we will send a small write-up. You will send a write-up, and AIVI will be the nodal agency. Yet this is what we will do, knowing this. And Raman spectroscopy, we have experience as well. So we will put all this capability. I'll make a multidisciplinary team, one expert from data analytics, one from AI, and one from sensor development, and then the AIVI, Virology and Immunology Center will be the main place to work with. So we will send a proposal to you to be as a collaborator in your R&D endeavors, so that we will add value, great value to this. And this will be useful to our country as well, and as well as other countries. So we will look at the export potential once you develop Mark 1 version, and we need to get certain regulatory approvals and also validation, third-party validation, as well as regulatory approval, so that people will know who has certified that it works. So we need to have that third party validation. So we'll be very happy, and I'm sure all our people will be, they are experts in the field. We will partner with you. And have a safe journey and back home. Anything else you like to know from us? And we have just begun our collaboration, the first step, and then we will sign a memorandum of understanding. So Meenakshi and both of you can look at the MOU to be signed between you, and also confidential.
Yes.
Yeah, we'll give our template. She is the director of yeah, Meenakshi. You have Meenakshi.
One last point that you were talking in your slides is really countermeasure system that just talk about before. So in the field of air quality and later on about water quality, because when we finished in a few years, we will go into the water, the liquid phases. We also very interesting about what Ms. said about the countermeasure purification system that we want to propose to people. Not all the systems are needed in every situation. So what we propose to the client is our own recommendation of the system they need to install, and so having more of those systems using different kind of technology can be really interesting for us. So at some point, if we can have a call or a share about that, it could be really interesting. And thank you a lot for your time. And
thank you. I wish you
did fantastically.
Yes.
Thank you so much.
Thank you. Thank you. And please stay back, because now we have to have discussion with her. So that is her area. And in the meantime, let us felicitate. Yes. I think we do want to and also yes, otherwise we cannot.
really share each other.
Yeah,
I will send you some mail with everything after the mission, and so we'll send a mail to everyone we met during the mission. So I hope we can have a call later on.
All the
Yes,
next year. Oh, funny.
Thank you so much.
She's the one who you're the coordinator. Louis. Carry a love and affection to your country.
Thank you, sir.
Come, Alok. Yes, sir. That time you have. Shukra, again. You will have me hot. Sunday. Good. Very good. Have a wonderful stay here. The rest of you are staying in. Yes, I hope you will be able to catch it. We will come back. Go outside. We will work together.
Yes, of course. With pleasure. Thank you for your invitation and this wonderful discussion for the work.
Yeah, thank you. Come, please settle down. Can you see the box? Can you put it? They will put it Bye. Bye. Come, let us continue with the university now. That industry part of the let us continue the discussion. Because the university, the areas which you mentioned is of great interest to us. One is space science and technology. You will be happy to know that there is a separate Amity Institute of Space Science and Technology. Some of the research which I will mention besides the courses which we run in avionics and also space science and also space technologies. Tanu, you can also come. You know. So we work in this area. Some of the projects is artificial intelligence based, the identification of fault in the spacecraft as it flies. How do you detect the fault? That is one project which we are doing. And the debris management, there are 37,000 debris in the low Earth orbit, which is above 10 centimeter size. So we have identified those. And then we have also developed a system for pattern recognition of the nature of the debris, because what is the size, shape, what velocity it is moving. These are all required for the debris management. So there is another project going on here in Amity. Since your interest is on debris management, so we have that debris management and debris detection, and also how do you switch on the pump, the motor, so that it gets deorbited to a level. So deorbiting is done as a management. Suppose your mission is in the path of the debris movement, then you can do that deorbiting. So that effort also we are giving support to ISRO. Then the third one is AI based, the Gagannauts, like astronauts. We call it as Gagannauts. How do you assess the health postures when they move inside the crew compartment? So that project has been approved by ISRO, that by using a smartwatch and the AI platform to identify the postures, that image processing. So using these two, one will tell about the vital signs like heart rate, blood pressure, respiration, and EEG, electroencephalogram, which will measure in a smartwatch and keep telling about the physiological health. The third one is the postural part. So there will be a camera which will identify the positions, postures, because they will be floating around in this crew compartment. So we have developed these two capabilities, AI based pattern recognition for postures. So this is on the space area. Then we are also looking at another project which has been sanctioned when they do the weldings in various components, particularly for submarines or even in spacecraft. How do you detect the failure parts using AI? The welding defects, welding faults and defects, particularly naval platforms as well as in the spacecraft. So this is another project which has been sanctioned recently. So like that, we have space science and technology very strong. In addition, astronomical research, there is one Dr. Suresh Chandra, who looks at interstellar distance. How do you measure using the chemical constitutions of the chemical molecules in space? You can use that for detecting the interstellar distance. So if you have to make an interstellar travel, then how do you detect the distance? So besides the astronomical using telescope, we can also use that. So there is a scientist here who does that type of astronomical research, Suresh Chandra. You can Google, he is in top 2% scientists, and there are 48 scientists from Amity in top 2% Stanford survey. And then this person, Suresh Chandra, is also one among them. You will see large number of publications. So we have an astronomy and astrophysics capability also here in Amity, which will be useful for your telescopic research. Then coming to biomedical engineering, we have a strong Amity School of Engineering and Technology with all, like starting from civil, mechanical, electrical, electronics, and also AI, deep learning, machine learning, all this capability in engineering is available, including robotic manufacturing. So we have an Amity Institute of Technology established by Tata's, the Tata Technologies who deal with automobiles. So we have a big institute here which deals with automobiles, aerospace, and manufacturing, robotic manufacturing. Then we also have AI Center of Excellence, which I mentioned, 10 petaflop capability of computing, and we are upgrading to 60 petaflop. So this is another capability which will be useful. And biomedical engineering, we have developed devices like, can you detect pesticides on the vegetables or fruits when you buy it? How would you know just by using mobile? So we have developed that device. So this also we will be able to share that information with you. So we have biomedical engineering, and then also to detect cholesterol, triglycerides, HDL, LDL, lipid profile. We have developed a sensor for detecting these biochemical constituents of your plasma, blood, or serum. So this is another capability which, since you met biomedical engineering, so we do such kind of biomedical engineering activities also here. Besides the sensors, which I was mentioning, gas sensors and ammonia and hydrogen sulfide, the toxic gases like methane for the sewer. If somebody has to go into the sewer to clean and all that, because it happens sometimes still in some areas. So how do we ensure the person who is working in the sewer? So the toxic gas detection. Then we have also organophosphorus compounds detections. So this again is very important, not only for detecting in the vegetable, the pesticides, but also even for the chemical warfare agents. So this is biomedical engineering. Then we have a Amity Institute of Defense Science and Technology. So where we have combat vehicles, aerospace, naval system, direct energy weapons, high energy materials, sensors and communications, and AI and cybersecurity. So these are the verticals in which we are working. And so all the area which you mentioned is of interest to us. So we like to now look at how do we move forward if we have to, if we don't have an MOU with them. So besides this, we can also look at academic collaboration. Say like we can do joint PhDs is one area where if you have a PhD scholar here, you can have a co-supervisor from your university. So this is, we can straight away start this. If some of these areas where your interest lies, if you can just pen down, then we will be able to identify the scholars who are recently registered for PhD and then be a co-supervisor. Then the joint collaborative R&D, when you look at bilateral Indo-Belgium collaborative project schemes are available. So we can submit proposals jointly with European Union also, multilateral. So we can have more than, yeah, so we can do that as well. So we can look at joint funding opportunities we can explore together. And besides that, we can have joint courses like dual degree, joint degree, and in the academic side, because now it is permissible to have this national education policy has given that flexibility. So we can have that type of joint degrees also, and also some of these students can be registered here, and then the degree can be given by you. Then it attracts people that, and also some of them can be, the degree is given by us, but then 2 years they get the exposure there. So 2+2, 1+1, all these models we can look at. Then if there are some integrated programs also, we can look at BTech, MTech integrated program in which we can even look at, let's say, dual degree. That is, you get one MTech here, one MTech there. So you can, because it meets the requirements here for an MTech if they do BTech, MTech 5 years. So 1 year you do over there. So you get the requirement 1.5 years there. So all this possibility we can look at as the collaboration. Then we can also send our master students for 6 months dissertation. They do one semester, 6 months. That last semester is for research. So we can look at whether if you can support their stay there, then they can also do. Similarly, we like to have your students coming over here. So we would like to have both ways. It's not one way. And so this also is possibility. So anything else, Admiral?
And all that was to be said has already been said by Dr. Salvamurthy, but I'll just add that I'm quite sure that the students in Belgium don't know much about India. And that is not their fault at all. So to give them an opportunity to know about India, we run a program called the India Immersion Program. It's a 2 to 4 week program. It can be tailor-made to your requirement. It can be done at the time of your choosing. It's a very popular program. We have got students from UK, Australia, Canada in the past that have visited us. The last cohort was of 200 students from Australia. I mean, we are not looking at that large numbers from your side. Whatever number is most welcome. During this attachment, we give them a real immersion of into Indian art, culture, customs, traditions. Take them on to Taj, to Agra, show them old Delhi, give them a real taste of India in many ways. I would request you to encourage your students to avail this opportunity. And I'll send you a mail giving you details of this program once I have your card. Thank you.
Thank you. Can you just give it to Kuna? No, you use. Because you met her, she said.
I think glad to meet you all here, and I am from Aerospace Department. My first suggestion is we are happy to collaborate on CFD-based solutions for AI, CFD and AI, so that we can create real intelligence data for the prediction. Whatever you are talking about, the virus or other things, we can have a prediction for real intelligence prediction. So that is very rare. Nobody has started it at physics-informed neural network program. So we are instead of talking about a CFD and AI, artificial intelligence, not artificial intelligence, is a real intelligence data. And secondly, another is space debris. We are having a lot of projects. We have published a lot of papers on space debris. We can have a collaboration on space debris. And we are having talented students. They are interested to come forward for undergraduate programs for the final year projects, full semester, as well as master's degree, both integrated as well as regular students. And we are having PhD students. They can have a training programs. Either it's there or here, we can have a degree that Dr. Selvamoorthy has already highlighted. So we can use our manpower. If you're having a fund, a lot of brilliant students will join in your program. That is my feedback.
Right. Murthy, you have any? Just.
Yeah. Good afternoon to all. So one important thing is that maybe we can have a joint R&D projects which are taking towards increasing the TRL levels with UU funding or Belgium funding, because a lot of projects here, they are at the prototype level, at the lab level, but taking it to industry, taking a lot of time. And some of the funding is required, which most of the industries in India may not be able to fund because they want early output or early returns on their investment. So that is one thing we can explore, some of the collaborative research funding for taking the prototypes into products. So that is one area. Second is, yes, AI is one of the thing, and data analysis, AI and data analysis combinedly, we can do a lot of works here. Either in healthcare, agriculture is very strong here. So some of these domains, yeah. So food technology is very strong here, and AI is another very major this one, and agriculture. So that these are the areas where we can. Yes.
So most of the points have been already covered by Dr. B.K. Murthy. So like I had mentioned about the sensors, sir has also mentioned about the biosensors, the chemical based sensors, the gas sensors, and other AI related products also. Like we have AI based software for the detection of male fertility. We have AI based platform for accelerating the development of vaccines for the diagnosis of the lung cancer and all. So these kind of platforms and the technologies which we are talking about, they are at low maturity level on the scale of technology readiness. So for that, and sir has already mentioned about the industries. The industries are mostly interested in taking the technologies at TRL 7 and above. In rare cases, TRL 6. So we are looking forward to have the collaboration in this field. So where the joint along with your university can be submitted to the funding agencies, and we can get the funding for increase the TRL. We can involve other industry partners also. We will not be restricted to only one. So we can look other industry partner from your country, from India, and we can move ahead. Yeah.
who spoke about oceanography.
Yes, yeah. So we are a very strong group in that, and we have a very strong group in environmental sciences per se. It is one of the biggest domain I would say in India. After TERI is one of the organization well known for. I hope you know the Energy Resource Institute in the area of environment, and MIT has come up to be the number two I would say, with the branches in wildlife and forestry, then sustainability, and then geoinformatics, environmental toxicology, environmental biotechnology, green technologies, oceanography, water technology. These are all institutes we have, and we have huge manpower and staff working in this area. And you name the funding agency here at India, we have projects with them. So first of all, we can file a project together in BRICS. In BRICS, we need different countries. So in that, in water resource management, because I have been to Belgium during my 1 month training at Wageningen, Holland. So that time I visited Belgium and I really loved your science city, and so we would be like to collaborate on water resource management. That is one of the big problem. And recently, this new government has announced. I gave an interview in Times Now yesterday in TV that they are going to develop a riverfront, and your country is very good in managing your rivers and develop them in in a recreational activity kind of thing. So in that, if we can do collaboration, that would be a great point. Plus, we have very pioneering courses like environmental health sciences. And then we have wildlife and forestry. We have MTech in geoinformatics and remote sensing. Then oceanography would like to, if you have, we would like to, have collaboration them. And recently we have registered a new scholar. We would like to have a co-guide from your faculty. I'll, share with you the topic which we are deciding. Yes, I've taken the even WhatsApp number. She's so nice to give you so that that has become a very convenient mode of communication nowadays. Thank you. Yeah.
Can I respond? Yeah, this is very exciting. I think there's lots of different opportunities. I want to respond to a few things. So we do have an oceanography. We have quite a large department, and our faculty of agriculture and agronomy has a number of forestry projects. We have an office in the Congo. So you may or may not know Belgium has a bit of a complicated history with the Congo, but we have a number of research centers that are located there, and an office with full-time staff who work with our projects. And so what we often, what eventually might be interesting is to do a three-way partnership, because in Belgium our forests are not quite as expansive as what you have here, but we definitely have the expertise and the research. The other thing is we have a number of oceanographic research centers. So in Corsica in the south of France and the Maldives. And so those obviously in a partnership would be something if you have students who want to go and do hands-on research in a different environment other than your own, it could be something that could be very interesting. We also have 9 Erasmus Mundus programs. So the Mundus are open globally. There's interesting scholarships. One of the things that we like to do is we get, I think about our business Erasmus Mundus who get 1,000 applicants for 25 scholarships. And the European Commission limits us to 2 individuals per nationality. But when we get 100 Indian students, how do we know? Right? And so what we look to our partners is we say, if you have students that that are applying to these programs, tell us, because then we can select them because we know that they come from an institution that's credible, that has the background. So I think that's and our Erasmus Mundus programs are not just in agriculture or business. We have them in science and materials and geo resources. So I think we have a lot of interesting opportunities there. The other thing, I didn't mention this earlier, but we have a very healthy and lively incubator and startup, and we have a startup club. So we have a long history at the university of encouraging our researchers to move into industry. We are next to our campus is an industry park with a number of now they're not so small and not real startups, but they were once upon a time. And so that's really something that's a priority for us in building those relationships with industry and in giving our researchers direct contact to make that move to industry. So I think that could be something that, perhaps if we look at a joint degree or a research project, that could be something that we could very easily contribute. And as you very rightly mentioned, the European Commission was here last week just before us. And so I think it really demonstrates an economic interest also to create more partnerships between India and the European Union, and then for us, specifically for Belgium. I also just wanted to highlight that I love the idea of the India immersion program, because it is true that we have a number of students that come, but I think having the two-way partnership is extremely important for the cultural aspects, but also for the research. It's a different way perhaps to learn research, to understand research, to see the impact. So I think we definitely have some interesting opportunities there. One maybe concrete thing just that I would like to offer is, I know, as I mentioned, my colleague, Professor Surdesh, they will be here for another 6 weeks, and they're the ones who are really leading the space debris project. And perhaps what we could do is put him in contact with you, perhaps, and over the next 6 weeks, while he won't just be in Delhi, he'll be moving around, but perhaps we could set up a meeting while he is here and maximize the fact that there's an in-person meeting that might be able to, and perhaps you could brainstorm together, perhaps some concrete next steps of, is there a specific project that would be of interest to you that we could work together on? And then that way we have something concrete to say. Jean Surdesh, I think your colleague has his name. He just wasn't able to be here this morning, but that way it also can help us perhaps to explore some possibilities for the future. So, but this.
I have 2 points. Like, one is, if you have industry-based internship program for our students, that will be very beneficial for us, and vice versa as well. And second one is, in space science, optical system design is one of the most important verticals. So if you have that in mind, or in future, maybe we can do collaborative projects based on that.
Yeah. Just one aspect about the industry. So often it's easier visa-wise for us, for students to come and have the industry part as a part of an academic course, because then they come in on a student visa at any level. So, but those are details that we can work out, but it's definitely a possibility.
Thank you so much.
Okay.
So I have 2-3 points. I am Professor Devara from University of Haryana, and also I wanted to cover some of the aspects given by Professor Raju, who is on leave today. In fact, we are working on ocean atmospheric science and technology topic, actually, with a special emphasis on environmental pollution and all these impacts on climate science, climate variability, and then climate resilience. So these are the things what our main focus. In fact, for this, to meet these objectives, we have developed a cross-cutting edge technology, equipment like air quality monitoring station, and we are working very closely with NASA in the effects of aerosols and their impact on human health as well as on climate change. And these are all the things what actually we are doing. We wanted to collaborate in these lines. How actually, in fact, I could not get the opportunity. Sometime back, we were talking about the sensor development for this thing, health aspects. So actually, using the Raman spectroscopy technique, in fact, when I was doing LiDARs, I developed a Raman LiDAR, which has the simplicity of having only one wavelength. You can use it for many constituents. That's the main advantage of that by observing the Raman shifts. So if the Raman shift has its own constituent relevant, so that the technique actually I was using in the LiDAR techniques. In fact, these are the things actually in our collaboration also we would like to, in fact, AUR, MT University Rajasthan, they have a small computer, hyper computing system. So actually, Dr. Raj will be focusing on modeling aspects of this, particularly how actually the aerosols impact on monsoon, how actually the aerosols impact on the human health. That is most of the thing in our meeting we were talking about. So these are all the things actually we wanted to focus in collaboration with other institutes. Like in fact, we have been closely working with the NASA and other things, other institutions, research institutions also. So these are all the main prominent things to understand, better understanding of the climate variability. And particularly, we wanted to know one of the aspects which were not known so far, because we have been concentrating, we have been trying to understand the pollutants, the what we call pathogens, what we are calling morning in our discussion, pathogens. My clarification, what I want is how actually the transformation of aerosol. In fact, we are using aerosol the source targets for studying the human health. But the thing is, how actually the aerosol information can be transferred into pathogens to identify as a biomarker to identify the diseases. This is very, very critical. In fact, we wanted to concentrate more on that in these collaborations. So, in fact, we are recently doing some superfine particulate mass concentration and the number density, which are very, very useful for detection of the pathogens. In fact, as a part of this study, we are making to understand the indoor-outdoor pollution relationships. Actually, that's also one of the very important area, but not many people are concentrating. So these are all the things which are very well suitable to have some sort of collaboration. And mainly, we wanted to know the vertical distribution. Say, for example, many people all over the world, they know PM 2.5, PM 10, PM 1, even superfine particulate matter. But all these studies are made only at the surface level. Nobody knows. Not many people knows. Even at 100-meter high, above the ground surface, what are the concentrations of this? Because pollutants are very dynamic. They are not stationary. So vertical distributions of these pollutants also play a lot of role in climate variability.
Yeah, thank you, Dr. Devra.
So these are all the things.
Dr. Neelam would like to also add on. Yeah, thank you so much. Devra is all very valuable. She will respond to it after she listens to Neelam as well. Dr. Neelam Upadhyay.
Okay, sir. Thank you very much for giving the opportunity.
Thank you, Devra.
Thank you so much, sir. This is Dr. Neelam Upadhyay from Amit University, Mumbai. I just have one query. Can we initiate some kind of internship collaboration for students? Because this way they may have some time to spend with the Belgium, I mean, your university campus and faculties. Even you will get some idea, and this could be like converted into an advanced program. They could be like what Dr. Selva Murthy had suggested earlier. They could be enrolled into an integrated master's program or PhD program.
Yeah, absolutely. And I think that's a good avenue to start with because it allows them to benefit from both. We also, I think in even leading up to that, looking at perhaps visiting faculty, it's easy for us to send faculty to find funds to send them so that they can create the territory, understand the lay of the land, and then set up, what courses
Absolutely.
attend, what companies, what would make sense for industry, and we can invite professors as well to do that exploration work. So absolutely, that's very good. So,
you want to respond to Dr. Devra, who environmental monitoring?
I just took some notes. I took a long list of notes of everything that you said because I think those are aspects that I can take back and share with our faculty. And again, try and find what would make sense both for you on your side and then for us. And for what's really, really important for us, and I work for the whole institution, is that our researchers need to have relationships. And then once they have relationships, then we find ways to make those relationships live. Because then we are assured that there will be a long-term impact. Those are the benefits. There will be publications. There's ongoing exchange of students. And so really my job is to find those partnerships and then and find ways to create the partnerships.
Thank you, Dr. Let me just mention some areas which were not discussed because they are not here. Agriculture and food. We have a very strong vertical in this area. We are looking at how do you enhance the agricultural productivity per hectare or per capita. That is the focus, where we are looking at microbial technology, the consortium of microbes which can do this job by giving protection against the biotic and abiotic stress, like low water availability, high temperature, low temperature, salinity of the soil, alkalinity of the soil. So, how do we use microbial technology? So, we have identified a root endophyte, which is known as Piriforma spora indica, which gives protection against the abiotic stress. And then similarly for biotic stress as well. So this is one area where we have developed technologies which have been transferred to more than 8 industry, one technology. So including one, the Taiwan-based company has taken this technology. So this is on the microbial technology. Right, right. That's what low water availability. Then the other one is biocontrol and plant disease management. Because we want to get rid of the sustainability and to assure this, that we are looking at non-chemical fertilizers. So one effort is biocontrol. That how do you use the pathogens or the nematodes or trichoderma for controlling the plant pathogens. So we are looking at biocontrol and plant disease management is another focus. Then we are looking at post-harvest management, which is very important for us because the country is very tropical and the temperature will go up to 45 degrees. You are seeing it in yes. So it's a big challenge for us. How do you keep the vegetables, fruits, particularly the farmers who cannot afford cold chain management, that you put it in the cold chain. So we are looking at zero energy cooling chambers, and also we are looking at the reversible blocking of ethylene receptors using MCP1. Then we are also looking at how do you economize the power using the sensor, which will differentially measure the ambient temperature as well as what's the temperature required inside the chamber. So this sensor development is another contribution from here. So we are having 3 efforts on post-harvest. Then we want to also double the income of farmers. Can we give 2 income to the farmers from the land? So one is from the crop, the other one is erect the poles, and then put the photovoltaic in slanting way. And then even in 0.25 acres, you can put about 40 of them, and each of these gives 300 watts. So you get 12 kilowatts, and you put 2 kilowatts for the use of the solar pump as well as other application. 10 kilowatt goes to the grid. So a farmer gets a very dual income. So this is another effort which we have done. So like that, agriculture and food is one strong vertical. The other vertical is cancer biology. See, cancer biology, we have a very strong group working on all types of cancer, whether it is cancer breast, cancer cervix, cancer pancreas, lung cancer, brain tumor, and so all type, including oral, buccal, head and neck, every cancer is being done here. But one thing novel which we are doing is for early diagnosis, we are using AI platform so that even before the stage 1 occurs, can you pick up the cases using AI? The second, on the therapeutic side, we are looking at a triple conjugate, that is using a known anti-tumor agent, curcumin and folate. And we are not attacking cancer cell, we are attacking cancer stem cell, so that the cancer doesn't recur after surgical removal, chemotherapy, radiotherapy. It comes back because stem cell is still there. Yes. We have Amity Institute of Molecular Medicine and Stem Cell Research. But for the patients, we partner with hospitals. We have an MOU with 12 hospitals. So including Rajiv Gandhi Cancer Center, and like that we have MOUs. So we get the patients and their samples coming from the hospitals. So this is a very novel approach to attack cancer stem cell to prevent recurrence, as well as to have the better prognosis. Then the next part is energy, green energy, which was not discussed here. We have a very focused attention on hydrogen mission, right from production, cost-effective production of hydrogen, storage, transportation, and its use. So we have all the 4 verticals for the hydrogen as a fuel. So we have a big mission on hydrogen. Then we also have the incubator. You mentioned about incubator, very strong incubator. If you have time, you can just on the way, Goodwill, if possible, you can just have a glimpse at just next building. And we have incubated more than 1,000 startups here. And we have our own venture, Amity Venture, which can also give support. If you have a brilliant idea, we can support through the grants. So we have the incubator and a very strong entrepreneurship development. This is also our mandate that we would like to have Atmanirbhar Bharat and $5 trillion economy we are moving towards. So in which these startups have to contribute immensely. So these are some areas which we were not discussed. So I thought I'll add on. We'll be happy to consider Erasmus Mundus schemes, European Union Commission, and also the India immersion internships. So all this we will put it in the MOU. So you can send the template, and we'll be happy to look at. We'll send it to you our template, and we'll listen to you your modification if any. But we like to build a strong partnership, Oriela, and we are so happy that you are here and come more often here, interact with our students. Let us build now the group interaction online. So maybe Zoom calls. Suppose you identify space science. Then once you go back, you connect those faculties, scientists who are working in that area. Then we will put up our, so Goodwill will take it forward. And then there is a horizontal interaction taking place because it never top down. It has to be faculty to faculty. So whichever area, agriculture, then we'll put those scientists across. So let us continue this dialogue, not just only signing MOU, but we need to get the outcome from those papers. So
I think we have a similar approach, so I think that's very exciting.
so here, Dr. Ashok Chauhan has made a concept, 3 missions, in which mission outcome is the most important. Mission connect, mission synergy, and mission outcome. So we like to have everything what we do has to have an outcome for us, outcome for you. Because it's life is very short. So that is why outcome oriented the dealings we always have, and we expect sustainable outcome. Not that you came here, signed an MOU, but what do we do afterwards? And that MOU is very important for us. So with this, thank you once again for coming here, and then we like to build a very strong partnership with you. Now, last word is from you.
Just thank you very much for the visit. Thank you for Goodwin for organizing, and this is, for us, this is really just the beginning. So our idea was to come to explore, and I think there's a lot of avenues for us to continue exploring. Some in the shorter term that we can connect people again in person, and then plan for a future visit. But as you said, in the meantime, online and continue to develop and understand where are the needs and how can we work together to meet those needs. So thank you very much for your welcome and your hospitality. Yeah. Okay. They can go there and have a discussion. Perfect. And what I can do is I will put Professor Jean in touch maybe with both of you. And then you can just, he will be in Delhi for the next little while, so that might be easy for you. But then you can give us a list, and based on his, where his travels, I don't know his whole schedule. Professors, they like to do their own things.
Yes. Do you have visiting fellowships also? I have been to visiting fellow to University of Derby for 2 years.
We do, yeah.
So we would like to apply for the same
Yep,
also.
definitely.
And in agriculture, there are 2 more inventions we have. One is a herbal pesticide and also one humic substance. PGPR, plant growth. So these 2 also, if you can connect with the faculty, it's a herbal pesticide, extract of a weed plant. So I'm working on weeds, seaweeds, terrestrial weeds. Yeah. Yeah.
Projects, what I can do is I can find professors who have similar topic interests.
Okay. Yes. Yeah. Thank you.
We can see who we have that works with Wageningen.
Okay. Yeah. Great. Yeah. It's Agriculture University, Wageningen. So yeah. Yes. Okay. Thank you.
So we have a small memento presentation. You will other people also.
Thank you very much. Very kind of you. Thank you. Thank you for hosting me. It was wonderful. Thank you.
Come again.
More days.
We should have tag them.
Thank you. See you. We're here in Delhi until.
So good when you are taking care.
And then we can go, this afternoon we'll have an event planning to leave at the area. Okay. That's planning. Very clear.
This is
Yes, he's here, so that's why. Yeah.